Hey guys, welcome back to one of these videos where I go through the 2024 papers or just past papers in general, and I go through the hardest questions on that paper to help, boost you from a grade maybe 5 or 6 all the way up to a grade 7, 8 or 9. Because again, these last few questions are the ones that people sometimes just get 0 out of 4, 5 or 6 on, and that's a big shame. So I'm going to show you how you can actually get a couple of those marks at least to help push you to the next grade, or to as high as grade as possible. Now, I picked the last 3 questions from this paper because honestly, this paper was kind of light, but paper 1 and 2 were kind of crazy, so it kind of makes sense. Now, that doesn't mean you should skip this because the last question was juicy. It was a crazy question, and I do think everyone should at least have a look at it because whilst it is very different to questions that we've had previously, it also has some similarities because once again, and if you've watched a lot of my videos, you know that I always say that the hard questions they put at the end always have something to do with a circle. And this is no different. It's still a circle-ish kind of question. We have to find the value of pi between 2 limits, which is very interesting. So again, without further ado, let's just jump straight into the first question. So this is the third to last question on this paper. Again, I don't think this is too crazy, but bounds is a grade 7 or 8 topic, so there's some people in here that might not know exactly what to do. So here it gives us P correct to 3SF, Q correct to 2SF, work out the lower bound for R. Now here's something I want to make 100% clear. Just writing the bounds, or at least one correct bound, gets you one of the 3 marks straight away. So even if you have no idea what the hell they're talking about, if you just write the biggest or smallest value for P, or the biggest or smallest value for Q, you get a mark straight away without any questions asked. So that's why, in my opinion, the best thing to do here is you get your 2 values and you just write the upper and lower bound, because you can get 1. I've even seen sometimes you get 2 marks for this, but 1 is guaranteed. Now if it's to 3SF, that means we look at the third number, we're going to add 5 after the number, so here it's going to be 5.885, and then we're going to just minus 1 from that number, if that makes sense, so 5.875. So again, all that changes with sig fig is you take the number, you plonk a 5 on the end, and then you just minus 1, so 0.01 in this case, and you get your other value. There you go, 1 mark done. Even though I have no idea what I'm doing in the question yet. Do the same thing with 3.6. So here we have the higher, or the upper and lower bounds for both numbers. Again, just plonk a 5 on the end, 3.65 times 10 to the 5, then minus a 1 from it, so here it's 3.55. Not bad, right? So, working out the lower bound for R. R is P divided by Q. So what they're basically asking you is, how do I make R as small as possible? Now, if I think about it, and I like to use really easy fractions to make it clear, right? If I have 1 over 2, and 1 over 3, 1 over 4, 1 over 5, as I make the denominator bigger, what happens to the overall value? Well, it gets smaller, right? Like 1/2 is 0.5, 1/3 is 0.33, 1/4 is 0.25, and so on. So in other words, if I want to make it as small as possible, I want to make Q as big as humanly possible. Because as I make a denominator bigger, the overall value gets smaller. Now let's do the same thing with the numerator. What happens if I make just the numerator bigger? Well, this one might be a bit more obvious. As I make the numerator bigger, the value is getting bigger. So if I want to make R as small as possible, I want P to be as small as humanly possible, because I want a smaller number divided by a bigger number. So if I take the lower bound of P, which is 5.875, times 10 to the power of 8, and I'm going to divide it by the biggest value of Q, which is 3.65 times 10 to the 5. And it says giving it as an ordinary number correct to the nearest integer. Yeah, okay, wonderful. So let's just shove this over here. 5.875 times 10 to the power of 8 over 3.65, yep, times 10 to the power of 5. Gives me, to the nearest integer, that's 1610. There you go. That's it. That's the correct answer. So again, not too bad. So where'd you get the marks? 1 mark for writing any of the bounds. So it doesn't matter, any one of these 4 numbers gets you a mark. Second mark is for choosing the correct bounds. So choosing the upper bound for the denominator, the lower bound for the numerator. The third mark is for getting the right answer, of course. That's it. This question I thought was fairly interesting. So we have a part A and a part B. It has a bunch of algebra and it says x minus 4, x plus 2 and 3x plus 1 are consecutive terms in an arithmetic sequence. Okay, so what does that mean? Well, if we think about it, it means that between these terms we add a certain number, right? So in other words, x minus 4, x minus 4 plus something, since it's different, should I say plus d, equals x plus 2. And we also have that x plus 2 plus d equals 3x plus 1. Right, because they're consecutive terms of an arithmetic series. I can also say that x minus 4 plus 2d gives me 3x plus 1. All of these equations would be a correct first step. So what could we do then? Well, I would just make this a simultaneous equation, right? So I might not use this one. I think I'll just use the first two that I wrote. By the way, there are other ways to do this. Just pointing that out. For number one, I'm going to move everything, all of the letters to the left side, all of the numbers to the right side. So if I minus x from both sides, I'll get 0. And I can add 4 to both sides, which means I get d is equal to 6. Right? If I minus x, then add 4. Okay, never mind. Then I can sub that straight into here. I get x plus 2 plus 6 equals 3x plus 1. So that's x plus 8 equals 3x plus 1. I'm going to minus x from both sides, so I get 8 equals 2x plus 1. Minus 1 from both sides, I get 7 equals 2x, which means x is equal to 7 over 2 or 3.5. That wasn't too bad actually, so I didn't even need to move everything over. We could just solve that straight away. Very nice. Now for part B, it's a very similar question, but this time it's a geometric sequence. A geometric sequence means that they multiply by something in order to get the next term. So for example, we could have 2, 4, 8, 16, where each term is being multiplied by 2. Now again, there are two ways to do this. I could say y minus 4 times d equals y plus 2, or, and I actually prefer this way, if I didn't know that I was timesing by 2 in each case, what could I do? Well, I could divide any two of the terms, any two consecutive terms, and I'll get 2, right? So why don't I do the same thing here? Y plus 2 over y minus 4 should equal 3y plus 1 over y plus 2. Then I'm going to cross multiply, so, and I get y plus 2 equals 3y plus 1, y minus 4. So that is y squared plus 4y plus 4 equals 3y squared minus 12y plus y, so that's minus 11y, and minus 4. Then move everything to the right hand side, so we get 0 equals 2y squared minus 15y minus 8. Now from here you can factorize, you can use quadratic formula, you can use completing the square, whatever you want. 5 marks! Oh my god, I didn't realise. But anything you need to solve it. So I'll show you the factorizing just in case you guys prefer that method. But again, any method you have of solving quadratics. So times to minus 16, add to minus 15 would be minus 16 and 1. Y. Cut it in half. We get 2y, y minus 8. Then that would be plus 1, y minus 8. So we get 2y plus 1, y minus 8. So our two values are either y is equal to negative 0.5 or half, whatever you want to call it, or it's equal to 8. There you go, for 5 marks. That's actually a really nice question. However, there was a question like this the year before, which was in a non-calculator paper, and it had surds and things like that. So, you know, it can get a little bit trickier. But let's move on to the question that is kind of crazy. Here it is. Here it is. It looks very complicated, but you know what the thing is? The actual math isn't bad. Let's have a look at it. So as you can see, we have a hexagon inside of a circle, which is inside of a bigger hexagon. And okay, it tells us some stuff about tangents and all that. It is relevant, but not right now. The key thing is it says by considering perimeters. So that gives us a really big hint. We need to show that 3 is less than pi, which is less than 2 root 3. Okay, so what would I do in this question? If I'm being completely honest with you, so obviously I had to go at it before I did the video because I don't want to get it wrong. I had no idea what to do at the start, so I just followed the instructions by considering perimeters. So I was like, okay, I'm going to try and find out the perimeter of the small hexagon, the perimeter of the circle, and the perimeter of the big hexagon. And then it dawned on me, right? We have this inequality. What do I know about the perimeters of these three shapes? Well, the perimeter of the small hexagon, so the perimeter of the PQ blah blah blah, is less than the perimeter of the circle, is less than the perimeter of the AB hexagon. Right? Because they're inside each other. So you've got the smallest, circle, hexagon. Now I know exactly what to do. We're going to find expressions for the perimeter of the small hexagon, the big hexagon, and the circle. And we know that the circle is bigger than the small hexagon, and the big hexagon is bigger than both of them. So, let's get started. Well, I think the easiest one is to do the circle. How do we work out the perimeter of a circle? That is just the good old-fashioned circumference. It's 2 pi r. There you go. First one done. Now we have to work out the perimeters of these shapes. Now, how do I do that? Well, logically, because they're regular, they're just going to be 6 times one of their lengths. So, for example, if I work out the length P to Q, 6 times that is the perimeter of the hexagon PQRSTU. Okay, so what can I do? Now, if you remember, and again, this is the first thing I did, it was almost like a reflex reaction, right? I know for a fact that you can break up circles into different shapes. Now, why did I do that? I did that because both of these lengths are the radius of the circle. Right? Logically. So, again, you do this in every single circle question that they ever give on the last question, is you break it up. Now, why have I done that? Well, now we have 2 radii. The interesting thing is, and I'm going to remove these other lines, is if I keep doing this around the whole thing, what do I get? I get 6 equilateral triangles. Yep. As in, all of these triangles are the exact same. They're identical. I shouldn't have said equilateral. I should have said isosceles. But they're all the exact same. So in other words, all I'll need to do is if I work out the length of this side and times it by 6, I get the perimeter of the circle. Of the hexagon, sorry. Okay, how can I do that? Well, that's a little trickier. I know that this is going to be 60 degrees for a fact. Because again, if I can divide it into 6 equal pieces, the angles around a point add up to 360, don't they? So that means, so again, if I go back to when I had all of these points on here, because all of these triangles are identical, all of these angles are identical. How many angles are there? There's 6 angles. Angles around a point add up to 360. 360 divided by 6 gives me the 60 degrees for this one. Cool. So, now I can get rid of that, being really careful not to rub anything else out. But that is the first thing that we're going to do. Now, I can use the cosine rule here to work out that opposite length. Right? I can use a squared equals b squared plus c squared, blah, blah, blah. However, to make it a little bit easier, what I can do is, because I know this would be 90 degrees, right? Because a radius meets a chord at 90 degrees. In fact, I've kind of spoiled the next part of this question now. But if I draw it just going up to here, that's 90 degrees. And that here would be 30 degrees. So now, if I draw this triangle out here, just to make it a bit clearer, we have a 90-degree angle, we have a radius, we have 30 degrees. I want to work out this side. So if I label everything up, we have hypotenuse, opposite, adjacent. So we have opposite and hypotenuse, we're going to use sine. So we have sine 30 equals opposite, the side we care about, over r. So the opposite side is r sine 30. So that side there is r sine 30. Cool. That means the total length, PQ, is equal to 2r sine 30. Which means the perimeter of PQ okay, no, we should probably write the whole thing, right? PQRSTU, PQRSTU is equal to 6 times 2r sine 30, which is 12r sine 30. But if you remember, sine 30 is a half. This is a calculator paper, so if you weren't sure about that, just whip out your calculator. Sine, whoa, careful, is a half. So that means it's 6r. Now, if you notice, do we do this now or shall I do it later? Okay, I can work out the lower value for pi. Actually, no, we'll do it later. Now we need to do the same thing for the bigger hexagon. So what I'm going to do is I'm going to just erase everything that we've just done. However, I'm going to do something very, very similar. Because what other information have they given me? They've said that each of the sides are tangents to the circle. So if I draw a line from here to here, that there is not the radius, sorry, but that is at 90 degrees. So if I make a right angle triangle, like that, where that's r, then I can work out the length of this side. In fact, let's change that. That's going to be r, right, because it goes from the center to the edge. And we're going to try and work out this adjacent side here. So once again, I'll draw out the triangle down here just to make it a bit clearer. Actually, I'll draw it over here. We have a triangle that looks... okay, that's a bit too terrible for me. Not bad. We want this side here. We have the radius, because again it goes from the center to the edge of the circle. This isn't the radius. I drew it initially going up to Q, which is the radius, but we're going to draw it as the whole line to make it an actual right angle triangle. So here we have, that's the hypotenuse. That there is still 30 degrees, just like it was before. That's opposite and that's adjacent. So we have opposite and adjacent. So we have tan 30 equals opposite over r, which is the opposite side is r tan 30. And once again, that's only half the length of A to B. That means A to B is equal to 2r tan 30, which means the perimeter of A, B, C, D, E, F is 6 times 2r tan 30. So in other words, 12r tan 30. And if you remember, tan 30 is 3 root 3. Root 3 over 3. So if we do 12 times that, whoops, we get 4 root 3r. Root 3r. So now we have our 3 perimeters, right? And what did I say initially? The smaller perimeter is less than the circle, which is less than the bigger one. So we can write this as a big inequality. We have 6r is less than 2 pi r is less than 4 root 3r. Now if you have a look at the answer, let's check out what's different. Well, the first thing is they've divided r away. Then they've just divided the whole thing by 2, right? So if I divide by 2, we get our final answer, which is 3 is less than pi is less than 2 root 3. Just like that. 4 marks is a bit crazy, not gonna lie. But to be fair, it's not super long. It's just very difficult to spot. But again, hopefully you can see how I use the question to get the answer, or at least get a couple of marks. So you do get marks for things like this. You get a mark for the r sine 30 and a mark for the r tan 30. You then get a mark for having a correct inequality, and then a mark for simplifying. So honestly, just getting the 2 sides might be a benefit. But hopefully that was useful to you. If you did find it useful, again, please do consider subscribing. It really does help me out. But I'll leave you to your revision. Good luck, and I'll see you in the next one.